Hello and welcome to the second lesson in our training, which involves the programming techniques. So, as we prepare ourselves towards the computing curriculum, we need to stay focused and then pay attention to all we're going to do. Watch the videos several times, try to understand if there is a concept which is not well explained, then we quickly draw our attentions and then we see how we can address that as well. So let's quickly look at the course outline for this particular lesson. That is the lesson 2 in the first phase of our training. So in here, we're going to talk of visual programming language, that is VPL. From there, we go ahead and look at problem solving process and techniques, the second one. Then the third one, we look at software development process. And then that will be the end of the second lesson in our training. So basically, that is that. So let's just dive right into it. But before we do that, let's look at the lesson objectives. So by the end of this lesson, learners will be able to, 1, explain what visual programming language is with examples. 2, state and explain the problem-solving process and techniques. 3, state and explain the software development process. And finally, 4, explain what an algorithm is and be able to write sample algorithms for a given problem. So these are the objectives of our lesson for this lesson 2. So let's dive right into what we have. Now, visual programming language, programming language, VPL for short. What at all is visual programming language? Now, in descriptions, visual programming language enables the development of software programs by manipulating a series of visual graphic elements instead of textual software commands. Now, what we are talking about here is this. You and I know very well, as we in our previous lesson, we said our programs, softwares that we use are developed using these programming languages, right? Good. Such as Python, C++, C#, JavaScript, Java, and all that. Now, in here, and we learned that before we be able to write a software, we have to understand those languages and be able to write our softwares using these languages. Now, there we come with another programming language called the visual programming language. With the programming like, or the programs like Python, C++, and whatever, you would have to write the codes by yourself. But with the visual programming languages, the source code is pre-written, and then the codes are used to create some blocks and some visual graphic elements, and are arranged in a way that what you have to do as a developer here is just to drag these blocks, snap them together, and create your software you want, or the software or the app or the program of your choice. So that is that. With the visual programming language, you don't have to write the source code from the source. No, you don't have to do all that. The codes are already written and are used to create a block. Yours is to pick up the blocks, snap them together, you get your software or whatever it is up and running. So that is that. So the graphics or icons included within a visual program serve as inputs, yes, activities, connections, and or outputs of the program. Now, when we write programs, in the course of writing our programs, at a point in time, we take input from our users, we declare variables, we talk of functions, we talk of lists, we talk of processes, and whatever it is. And using any other language aside this visual programming language, you will have to write the source code for all that. To declare variables, you have to write the code. To call a function, you have to write the code. To write a function, you have to write the code. To create a list, you have to write the code. To display something, you have to write the code for that. But with the visual programming languages, all these codes are already written and are used to create blocks. So if you take this visual programming, one of these visual programming languages, we have the block for taking input. You don't have to write a source code. We have the block for displaying output. We have the block for connections. We have the block for process and all that. So you just take them and arrange them, snap them together to create any software you want without you writing the source code or the syntax of any program. That is that. Wait, what is the main aim of this? What is the brain behind this VPL? That is the visual programming language. The main aim is to do what? Is to enable or is to make programming more accessible to what? Beginners. Those who find it difficult to write the source code. Those who find it difficult to learn a programming language like Python, C++, JavaScript, Java, and all that. With the knowledge of this visual programming language, which makes it easier, no coding. You just have to drag the blocks and snap them together. They also feel involved in the field of programming because they can also, at the end of the day, be able to create something out of these visual programming languages. So let's look at some of the examples of these visual programming languages. We have the VB, that is the Visual Basic. We have the Code, we have the Blockly, and then the executable UML. We also talk of Scratch. We talk of Mobilize. With the Scratch, we in our previous lessons, we dealt with Scratch, where we use Scratch to create our own games, our own stories, and all that. And we talk of web development, where if you want to develop a website for yourself or whatever, you and I know very well that the core component of developing a website, you should understand CSS, HTML, that is cascading style sheet, HTML, which stands for hypertext markup language, and then the JavaScript. This forms the core component of a website. So to develop a website for yourself, you should be able to understand all these, what do you call it, scripting languages to be able to develop a website. But with a visual programming language for web called the Mobilize, what you need is the Mobilize software. Install it in your PC. You look at the layout of your website, how you want the design of your website to be. From there, you just go for your blocks, the Mobilize, drag them, snap them together, do some little editings, take out some things, and fix your own custom logos and all that to get your website up and running without even have to learn HTML, CSS, and JavaScript. So that is what these visual programming languages are all about. So that is that. Now let's look at problem-solving process and techniques. With what the programmers see this world is about. The world is about problems, and for that matter, and they also believe that each and every problem has its solution. So they came out with this problem-solving process and techniques to be able to solve a problem, to write a program or software. For the software to be used to solve a particular problem, there are some techniques and processes you have to follow. So basically, that is what we are going to talk about here. So to create a suitable plan of action to solve any given problem, such as providing travel instructions for a friend, we need to devise steps to go about it. It could be that you visit the hospital and you've detected a problem as a programmer, and you want it in a way that maybe their system is being slow, or in one way or the other, there is something you want their system to capture which is not capturing. And you, as a programmer, you would want to what? Write a program to be able to do something like that, to be able to achieve this. Or maybe with the example given here is a travel instructions for a friend. Maybe you want to create an app, and this app should be used for what? Giving traveling instructions and all that. To be able to do that, there are some steps you have to devise. There are some steps you have to write down and follow. And this brings us to a term called an algorithm. Algorithm. What is an algorithm? Now, an algorithm is a sequence of steps for solving a specific problem, giving its inputs, data, and then the expected outputs, or whatever it is. Basically, in summary, in short, algorithms involve the steps or sequence of steps we write, after which we follow these steps to solve a given problem. So in writing our algorithms, at a point in time, we take input from our users, we process it, and we give output and all that. So writing all these steps and following these steps to solve a problem becomes an algorithm. So it can also be described as what? Step-by-step problem-solving process in which a solution is arrived at in a finite amount of time. Basically, it's just talking of the same thing, where we write steps to arrive at a solution of a given problem. Is what we term as what? An algorithm. You can prompt your student in class to outline some of the problems they have, being it in their lessons, at homes, and all that. So after outlining all these problems, what you as a developer or whoever has to do is maybe try to guide them as a teacher. Now, after writing this, after they stating these problems or challenges they face, or problems in general we call them, write the problems down. After that, take out one of the problems. You can clean the rest, pick one of them. Now, let them suggest possible way or solutions for possible solutions for solving the problem. So as they write, or as they state them, you write them systematically, step by step, sequentially, in that order. Then after that, you follow the steps and see whether it can solve the given problem stated by the children. If yes, then it becomes an algorithm. From there, they understand what an algorithm is. They understand that the sequence of steps we write, which we follow to solve a given problem, is what we term as what? An algorithm. So that is as simple as that. Now, so we often apply general problem solving strategy. Before we write any given, or before we approach any given problem, before we try to write a program to solve any given problem, first of all, what we need to do is to what? Try to understand the given problem completely. We have to try to understand the given problem, understand it. After understanding the problem completely, then we devise a plan of action to solve the problem. Now, in trying to understand the problem, you ask yourself a series of questions. How am I going to tackle this problem? If I do this, will this work? Ask yourself all this and try to answer these questions by yourself. After understanding the problem, the next thing you have to do is to devise a plan of action to solve the problem. So by providing precise step-by-step instruction, this involves writing the algorithm. So after understanding the problem, write the steps you're going to follow to solve this problem. Writing these steps, or the steps here are what we term as what? The algorithm. After that, you carry out the plan. Carrying out the plan means you want to implement your algorithm. You want to follow your steps you've written as the algorithm and see whether it can help solve the problem. Then after doing that, review the results. After that, check and see, has it solved the problem? Did your plan work? Did your algorithm work? Has it solved the given problem? If it solved the given problem, bravo, you are good to go. If it fails to solve the problem, it means there is something wrong somewhere. And you have to quickly go back and check out all that. Where there is a problem, you fix it. And make sure the algorithm solves the given problem. Now, these steps we follow to create a computer program, in simple, mimics this general problem-solving strategy. We talk of problem-solving strategy. This involves the steps we just talked about. The process of trying to understand the problem, devising a plan of action by writing your algorithm, by writing the steps you're going to follow, implementing your algorithm or carrying out the plan, and then reviewing the results and see whether your algorithm or the problem at hand is solved using your algorithm is what we term as what? Problem-solving strategy. So basically, that is that. Let's try to always understand the problem before we tackle it. Let's make it part of us. That is that. We are still on the problem-solving process. Now, let's look at the following steps. It's the same thing that we are talking about. The steps we follow to solve a given problem at hand. We have to analyze, first of all, we have to analyze the problem and outline the problem and its solution requirements. So we'll try to understand the problem, we analyze it, and the requirement we need to be able to solve this problem. We state all this down. Then after that, we proceed and design an algorithm. We proceed and write the steps which we are going to follow. After writing the steps, you realize that when tackling the problem, it makes it easier for you because the next thing you do is just to follow your own steps you've written. You follow your own algorithm and then you solve your problem. Then after that, we implement the algorithm in the programming language. Before the program or the software can be accessible or you can make it available on the internet, it has to be written in a programming language, make it executable so that any user anywhere can have access to it and also what? Use it to solve the problem at hand or whatever it is. So after designing your algorithm, you implement your algorithm in a programming language. Maybe it could be that you only know Python. You use the Python to solve the problem. If Python can do that, you are good to go. You use it to do that. If not, which of the languages do you know? If you don't know any of these languages at all, we just spoke of what? Or we just talk of what? VPL, Visual Programming Languages, where you don't have to write the source code. You don't have to write the syntax. You only go for them and then you use them to design a program. So you have it up and running. Provided it can help solve the problem, you are good to go. Then after that, you verify that the algorithm works. So after that, after implementing your algorithm using any of the languages, being it VPL or any of the scripting or visual or the other programming languages, you verify and make sure that it solves the given problem. That is what we mean by verifying that the algorithm works. Then after that, we try to maintain the program by using and improving it and modifying it if the problem domain changes. After writing a program, The program, as a developer, after writing your program, the program shouldn't be rigid. It should be flexible. It should stand for, it should be able to stand some changes at a point in time. Because a lot of things happen all over the internet. As a developer, after writing your program, you can decide to make it an open source, where you can leave it on a website where others, users go to download and then use it to solve the problem that the software solves. Or you can make it a premium one. You want to make money out of it, you can make it premium, where users have to pay some amount of money before they can have access to your software or all that. Now, in all this, we have hackers and crackers. If the software or the program takes data from users, such as their full names, their ID numbers, their staff ID, we all know how important and sensitive all this information or all these data are to us. You and I know very well that anyone who lays their hands on our staff ID and our names and all that can use them to hurt us at a point in time. So we should be very careful. If the program you develop or the software you develop or the app you develop takes this information, it means that it should be secured, and then the data must be protected from these hackers. At a point in time, the hackers, what they do is they try to break these softwares, and then the crackers as well, they also try to use them, break them down for their own selfish gains. So as a developer of the software or the program, you should be able to fix these errors whenever they crop up. So that is that. And then the crackers, if it is a premium software, what they do is that they crack it and make it free for others to use. We are all using those softwares. God forgive us. We are using them. So that is what they do. If it happens like that, as a developer of the software, you should be able to fix this problem and make sure that everything is up and running. If the software or the program solve a particular problem, and at a point in time, the domain of the problem changes, you should be able to change the software to match with the problem at hand. So that is what we mean by maintaining the program and improving it and modifying it if the problem domain changes. So that is that. So these steps here involves what we term as well the problem solving process. So that is that. Now let's look at program development cycle. So the process of analysis, where we try to analyze the program or the problem at hand. Then from there we design our algorithm. Then we implement our algorithm in the programming language. So let's look at this step by step very well. The process of analysis, where we try to analyze the problem at hand, understand the problem, look at the system requirements and all that. And after that, we design our algorithm. After designing the algorithm, then we go to coding. Now, what is coding here? This is another big word we use day in, day out. Now, here we go. Let's try to understand it. Coding here means implementing your algorithm in a programming language, where you can talk of Python, C++, or whichever programming language you understand. Use it to write the syntax. So the process of writing the syntax or the codes to implement your algorithm is known as what? Coding. Coding means writing the syntax of a program. So that is that. So in implementing your algorithm in a programming language, where you choose one of the programming languages, then you write the syntax. The process of writing the syntax is what we refer to as what? Coding. And then testing forms the core of what is known as what? Program development cycle. So where you analyze the problem at hand. After analysis of the problem, asking yourself a series of questions, you go ahead and then design your algorithm. After designing your algorithm, you come to coding, that is implementing your algorithm in a programming language, write the source code and all that. And after that, you test it. All this process forms the core of what is known as what? Program development cycle. Now, the word cycle is used here because it's like it's in a circular form. After analysis, we come to designing of the algorithm, then we come to coding, then we come to testing. And then after everything, we have to, during the testing, it could be that something fails to work. What it means is that we have to go back to the initial state, that is the analysis once again, come to our algorithm once again, and to the source code once again and all that. So going around all this thing, trying to fix or solve the problem is known as what? Problem development cycle. It's like it's in a circular form. If you go the first round and there is a problem, you have to go to the initial stage again and start all over trying to fix the problem at hand. So that is what we refer to as what? Program development cycle. So that is that. Now let's look at software development process once again. Here, what they are telling us here is this: developing a software product is an engineering process. In fact, this is pure 100% true. To develop a software product to help solve a particular problem is an engineering process because it involves a lot of critical thinking, analysis, writing of algorithms, implementing your algorithms, testing, reviewing your results, maintaining your software, deployment, and all that. In fact, it involves a lot. It's a pure engineering process. So that is that. So let's come to say software product, no matter how large or small or how small, have the same life cycle. It could be that the software you want to develop to solve a particular problem is a very small one, or a big one, or whatever. They all follow the same software development cycle. And what is the cycle we are talking about here? This involves the first one, requirement and then specifications, where we try to understand the problem and its requirements. After that, we analyze the problem and its requirement as well. After the analysis, we go ahead and design our algorithm. After design of our algorithm, we implement our algorithm. How do we implement our algorithm? It's by using a programming language to write the source code and make it executable or whatever. After implementation of your algorithm, you test it. You test it and make sure that it works. It solves the given problem. Has it solved the given problem? If yes, you are good to go. If no, you have to go back and fix it. You have to go over again and check where the problem is and fix the problem. So basically, that is that. So after all this, a minute, please. So we have to, sorry for the interruption. So first of all, we look at the requirement in its specification. We look at the analysis. We look at the designing process. That is the designing of the algorithm. And then we come to implementation of the algorithm. You implement your algorithm using a programming language. You test it. Make sure that it works. After testing it and it's working and it becomes an open source software or app or program, then you have to think of maintaining it from time to time. If there is something happening, you have to quickly fix the problem. If the software, the program is leaking some data or whatever, you should be able to stand up to it and fix this problem. That involves the maintenance and all that. So that is that. Now, this is the diagram showing the software development process, where we have requirement specification, we have the system analysis, we have the system design. Now, the requirement specification, system analysis, system design forms the input, process, and output. So after that, we implement our design. That is the algorithm here. After designing it, then we implement it using a programming language. That involves the implementation stage. After implementation, we try to test it and make sure that it solves the given problem. After that, then we deploy it, and then we go ahead and maintain it. Deployment and the maintenance here work hand in hand. From time to time, you cross-check and see that is it really solving the problem? What are the users talking about it? Are they saying that it is solving the problem, or are they saying that it's not solving the problem? Sometimes when we visit the App Store to download programs and all that, we go to the reviews section and you realize that users complain, have a lot of issues they raise about some apps and all that. These are some of the things as a developer you have to take note of. Listen to your users. What are they saying? It could happen that to you, the program solves the problem, but to them, it doesn't. If it doesn't, you have to listen to what they need, the requirement, what are some of the things they are talking about. If you can do that, you fix all that, you deploy all that, then try to maintain the program, make it workable. That is that. Now, let's look at how we can write simple algorithms. How we can write simple algorithms. Simple algorithms. So by the end of this, we should be able to explain to our peoples the concept of algorithm, guide them, let them bring some problems. We try to write algorithms and all that. Let's try to make our platform, the WhatsApp platform, very effective by using trying to get some problems and then writing algorithms on our own, try to solve these problems. Please, this is what makes you creative, and it makes you think deep always. It makes you think, and whenever you see a problem, to maybe challenge yourself to solve the problem becomes easy. You don't have to even suffer because you are used to it. So let's try to make it part of us. Now, let's see how we can write simple algorithm. The first one says what? Design an algorithm to find the perimeter and area of a rectangle. So this is a problem. Our students want a software or simple app that can help them find the area and then the perimeter of a rectangle. So how do we do it? So this is a problem. So we have to think of understanding the problem. Now we understood the problem. Basically, we want to write a software to find the area and perimeter of a rectangle. It's not about the circumference or whatever it is. It's about area and perimeter of a rectangle. So that means we have understood the problem. Now let's look at the solution at hand before we proceed to the algorithm. Say, to find the perimeter and area of a rectangle, there is something we have to take from our users as input. For example, if you design a calculator, for the calculators we use before we can sum to get or whatever, maybe if we want to find the product of two numbers or more, sum or difference or division and all that, we have to enter the numbers, right? So entering the numbers at the keyboard level becomes what? The input. So in here, our input is going to be, basically, in the course of our training, we're going to be talking of data types. Then we see the data types we need from our users at the point when we are creating our programs. We'll see all this. And don't forget, all these algorithms we are talking about here, we are going to implement them in Python programming language. So that is what is making the program more interesting. We're going to implement all these algorithms in what? Python. You see. We're going to write the codes and run them, and you see that it's working perfectly after following our algorithms here. So the first thing we need is to get the length and then the width of the rectangle. After getting the length and the width of the rectangle, then we find the perimeter using this formula, 2 times length plus the width, or 2 times the sum of the length and then the width. And then the area as well, the product of what? The product of what? Length as well as what? The width gives us what? The area as well. So basically, that is the solution. Now, let's see how the algorithm is written. The algorithm to find the perimeter and area of a rectangle. First, so algorithm, this is how we write it step by step. Step 1, you do this. Step 2, you do this. Very straightforward. You don't have to write a lot of things just to get yourself confused somewhere. It should be straightforward, systematically, sequentially, and all that. You don't have to write a whole essay for people to be reading, and then before they get to the bottom of the essay, they've even forgotten of the top, of what is happening at the top, or the first stage and all that. It should be simple, straightforward, and easy to follow as this. First one is get the length of the rectangle. After getting the length, get the width. Get the width of the rectangle as well. After getting these two, then that becomes our input, right? Now we have to process it and give out the output. So the process, at this stage, this is the stage of the process where the sum of the widths and then the length is going to be multiplied by what? 2 and give us the perimeter becomes the process. And then at the point where the perimeter is displayed becomes what? The output. So that is that. Now from there we proceed and find the area as well using the formula here. The area is equal to what? Length times width. At the point of multiplying the length by the given width becomes the process stage. And then at the point of displaying the results as the area or the product of this becomes what? The output. So this is a very simple algorithm. So that is that. Let's look at another example so you can guide your students to understand this, and then from the time you finish explaining all these things to them, they can be able to what? Approach any problem given to them. Because at the end of the day, they know that if this is the problem, I'll have to write the algorithm, which involves the steps I'll follow. So after writing the steps, that you can easily follow the steps and solve the problem. So let's look at the second example. The second example says, design an algorithm to find the circumference of a circle. Here we are talking of the circumference of a circle. So we have to make sure that we understand the problem. And here we have understood the problem. So you can pause this video at this level and try the algorithm by yourself. After that, you can then move forward and see the solution and compare it to yours. If it matches, you are good to go. So that is that. So now let's look at the solution. So to find the circumference of a circle, you need to know the circle's radius. That is that. And also the pi. If the pi is given, then what you need to get is what? Only the radius. If the pi is not given, then you need the pi as well as what? The radius. And after getting the radius and your pi, then we use this formula, which says circumference is equal to what? 2 pi r. So we multiply the pi and then the radius by the 2, and that gives us what? The circumference of the circle. So this is the solution. Now let's see how the algorithm is written. So write the algorithm for implementing this. So pause this video at this level and try writing the algorithm. Now let's check the solution. Good. There we go with the solution. So the the algorithm to find the circumference of a circle. 1. Get the radius of the circle. So first of all, we get the radius as the inputs. 2, we get the pi, which sometimes it's given, sometimes we have to, we know that it's always given us. So, and we also know the pi by default, which is 22/7 or 3.142 and all that. So that is that. So after getting your radius and your pi, the next thing you are going to do to be able to get the circumference of your circle is what? Use the formula here, 2 pi r. So you multiply your pi by the r by 2, and that gives you what? The circumference. So the question is, has it solved the given problem? Yes. If it's solved, it becomes an algorithm. So that is that. This is another simple algorithm. We are going to implement this in our Python programming language. So in fact, just be anticipating to see that you are going to write this by yourself, and from there, I promise you, you can challenge, you can tackle any problem that comes your way. If it happens that during the process of solving the problem, you face challenges, the internet is there. YouTube is my friend. YouTube is my school. Udemy is my school. Coursera is my school. So these are some of the websites where have videos. Sometimes we can stay up all night looking for solutions to given problems. That is, as a programmer, if you dream to become a very good programmer, that is what you should be doing. It makes you think. That is that. So this is the second example. Let's proceed to the third example. So you can equally pause this video at this level as well. Try this algorithm by yourself. After that, you compare it to what we have for you. So is it write an algorithm to convert weight from kilogram to pounds? We are converting weight in kilograms to pounds. So we understood the problem, right? Good, it's understood. So let's make sure we understand the problem before we tackle it. So to be able to do that, first of all, we convert weight from kilograms to pounds by doing what? By dividing the given weight by what? 0.45. And that gives us what? The weight in pounds, the weight from kilograms to pounds. So that is that. So let's see how the algorithm is written. So pause this video and write the algorithm by yourself, step by step. After that, let's compare the answer to yours. Are you done? Now let's confirm the answers. Now this is the algorithm for that. The first step says what? Get the given weight in kilograms. 2, divide the given weight by 0.45. And then 3, is a weight, that's weight divided by what? Weight in kilogram divided by what? 0.5 gives us what? Weight in pounds. So this is the algorithm. It can happen that your steps are more than this. It doesn't matter. What matters is that after that, ask yourself, test it. Has it solved the given problem? If it does, it becomes an algorithm. Don't just think my steps are 3 and yours is 2, and for that matter, no, it doesn't matter. Yours can be 4 and mine is 3. It doesn't matter. Algorithm is algorithm. The question here is, does it solve the problem? If yes, it becomes an algorithm. So basically, that is that as well. So this is the third example. Now let's go to the final example, the fourth example. Fourth example says, design an algorithm to find the age of a user. Let's try to understand this question, the problem very careful, very well. So design an algorithm to find the age of a user. They didn't say the date of birth of the user or the year of birth of the user. They say what? Age. Sometimes when we hear age of a user, we think of date of birth where we say 4th April 1985 or whatever it is. Here we are talking of just the age. What is your age? I'm 25. What is your age? I'm 39. What is your age? I'm 54. So we are talking of the age here. So they said to find the age of a user using the birth year and then the current year, what we just have to do is to subtract the year of birth from the current year. And that will give us what? The age of a user. So basically, that is that. You just have to what? Subtract the year of birth from the current year. If my year of birth is what? 1979, what I will have to do is to subtract it from the current year, which is what? 2021. So 1979, 2021 minus what? 1979, and that gives me what? My age. That is that. So let's see how the algorithm looks like. So pause this video here and try it by yourself. Are you done? Let's confirm the answers. an algorithm to find the age of a user. Step one, get the year of birth of the user. So you have to get the year of birth of the user. After getting the year of birth, you find the age of the user using what? Age is equal to current year, which is 2021 minus what? Year of birth. If the year of birth of the user is what? 1944. Subtract 1944 from what? 2021. And that gives us what? The age of the user. There's the age. So the question is, has it solved the problem? If yes, bravo, we are good to go. If no, then we have to go over again and make sure it solves the problem. Like I said, your steps can be more than this. It doesn't matter. It can be less than this. It doesn't matter. Mine is 3. Yours can be 5, 4, 2, whatever. So far as the question is, if it solves the problem, then you are good to go. If it doesn't, you have to make sure that it solves the problem. That is that. Now, we have to try the following by ourselves. But then before we look at all this, I think this is just leading us to the end of this lesson. That is the lesson 2. Let's just summarize what we've talked about. We started with the VPL, that is the Visual Programming Languages. We talk of their aim is just to make programming accessible to the beginners, since it doesn't involve writing the source code, the syntax. The blocks are there for you to snap right. And we talk of the examples. Typical one is the Scratch, and the kids are used to the Scratch. That is why I'm always stressing on it. And we also talk of problem development cycle, or program development cycle, where we talk of understanding the problem, writing the algorithm, implementing the algorithm, testing the algorithm, deployment, and the maintenance. So we talk of all this. Let's make this part of ours. And then we try to explain the concept of algorithm to our students. Let them understand. We can use the following slides to also explain it more to them. We can use our own examples in addition to what we have here, and then explain to them. By the time you finish explaining this concept of algorithm, wherever they go, it will remain in their head forever. So I pray you understand the concept of algorithm from today. And wherever you go and the term algorithm is mentioned, you smile because you know what they are talking about. If a problem is posed on the board, you know where to start. You know where to start with a solution. You know that I have to write the algorithm. So you go ahead and start that. That is the work of a programmer. So that is that. Let's try to follow these ethics, and then we'll be good to go. And we'll be successful. And we'll achieve our dreams as programmers. First of all, let's look at what we have to try. So design an algorithm to implement the following. 1, we have to convert weight from pounds to kilograms. So to do that, we have to multiply the given weight in pounds by what? 0.45. And that gives us the weight from pounds to what? Kilograms. In the example, we converted from kilograms to pounds. So this is the vice versa here. And then the second one, we have to find the year of birth of a user using their age and then the current year. So here too, we are talking of the year of birth and not the date of birth. So just the year. Which year were you born? 1944. Which year were you born? 1983. Which year were you born? 1987. Which year were you born? Year, just the year. So to be able to get the year, we need the age of the user and then the current year. So what do? So to find the year of birth of a user using their age and then the current year, we subtract the age. What is your age? 45. From what? The current year. So if it's 45, 45 minus what? 2021. And that gives us what? We subtract, 45 minus what? Yeah, 2021. And that gives us we subtract the age from the current year, right? If your age is 45, so we subtract 45 from 2021, and that gives us what? Your year of birth. So we have to write an algorithm to what? Implement these 2 problems. So basically, that is what we have to try. Let's try as much as possible to do that. And after this, it shouldn't end there. Let's try to pose problems to ourselves as far as programming and then other problems around us are concerned, and write algorithms for that. And then put them on the platform. Let's all go through them and then appreciate them. Let's make it part of us. Let's try as much as possible to make it part of us. Yes. Let's do that, and then from there we'll be good to go. We'll be used to writing algorithms. We'll be used to what? Tackling or solving problems, since we want to become programmers. Because what programmers do is to look around. What are some of the problems they encounter in their workplaces? Or what are some of the problems workers and other people encounter? So they look at this problem and try to write programs and software to solve these problems. So as a developer or a programmer, this is what you have to do. So let's try as much as possible to follow all these ethics, and then we'll be successful. So thank you very much for watching. And this brings us to the end of lesson 2. So, till our next lesson, which is lesson 3 of the first phase of our training, I say thank you very much for watching and bye for now. Watch the video over and over again. And if there is any question that is bothering your mind, you throw it and then we see how we can address it. God be with us all. Bye for now.